Good afternoon. My name is Sheyanu, Odeyemi, a structural engineer from Nigeria, and I'm presenting my master's thesis on BIM Plus, which is titled Bi-directional Interoperability between Architecture and Structural BIM for Efficient Design and Analysis. First of all, let's pick in the keywords from the title, which are the architectural BIM, structural BIM, bi-directional interoperability, and structural analysis and design. We all know that the architectural BIM and the structural BIM are key in any project, in any construction work or any project before construction. Before a structural BIM can come in place, the architectural BIM. Okay, let me just introduce what BIM is. BIM is the creation or management of digital representation of physical characteristics and functional services of a building. Architecturally, we are talking of building elements when we talk of the architectural element, while talking about the structural element, coming to structural beam, we talk about the slabs, we are talking about the columns, beam, all structural elements that makes a building or an infrastructure work. That's what we call basically a structural beam. Now going to bidirectional interoperability, the key thing is the connection between structural beam and structural analysis software, because there has been actually a situation, a problem where the connection between the BIM authoring platform, um, Revit or any other software, and the finite element modeling software, which we can be any finite element modeling software like Autodesk, robots, and the rest. It has been a big issue when it comes with structural analysis and design, where we have to design and bring back from the FEM platform to the BIM authoring tool. So these actually dive more into a way which it can be done using a plugin, an add-on, or using IFC. Now, going to the scope of the research, the two major softwares that I was actually using in the project was Revit and ProtaStructure. ProtaStructure is the structural analysis software actually, which is prominent in most parts of Europe and also in Africa. And talking about Revit, which is also a BIM authority, you can see for the scope one, which is passing our Revit, our structural model from the architectural platform, which is the Revit, through the IFC, through the bidirectional link, which is ProtaBIM, to the ProtaStructure software, which is the FEM platform, finite element modeling platform. And the second case study is actually passing the model from Revit to ProtaStructure using IFC. Now, the aim is obviously to evaluate interoperability between the architectural and structural BIM for structural modeling analysis and design using bidirectional link and IFC. Now, the objective was actually to develop a practical workflow for passage of structural modeling analysis and design between these two softwares, and also to evaluate the structural BIM model evaluate the structural BIM model and data interoperability between these two softwares using the bidirectional link, and also evaluating using the IFC, then checking for discrepancies and also evaluating the discrepancies. Going straight to the research methodology, we can see that we have two case studies, case study one and case study two, whereas the first case study is passing from Revit platform to the analysis platform, which is ProtaStructure, using the ProtaBIM add-on plugin from ProtaStructure between the Revit and ProtaStructure. Now, the second case study is using IFC. In the first case study, we can see that it's the first trip, which is highlighted, also comparing the discrepancies and checking the model after export from Revit through the bidirectional link, which is the ProtaBIM and IFC. And the second trip is the import of the analyzed and the design model from ProtaStructure to ProtaBIM, checking the loss the geometry, the factors that was evaluated. Now, talking about the research methodology for the first, we can see that brutal beam as a bidirectional link here appeared after the structural beam, the structural model was done in Revit, which was passed through the add-on through the plugin Brutal Beam before it was loaded into Brutal Structure. After design, it was also passed through Brutal Beam back to Revit. We can see there's a plugin also called Brutal Details, and this is an independent plugin from Brutal Structure where you can easily develop a shop drawing straight from after analysis and design, but that was not actually the scope. The scope was to pass the analyzed model, the design model from Portal Structure, which is the FEM platform, through the Portal Beam, through the bidirectional link to Revit for further production of shop drawing and drafting. The second is the IFC. This is the passage of the structural model from Revit through using the IFC format. We can see that the IFC model viewer used was Solibri. Before we can actually pass the IFC model from Revit to Portal Structure, we have to check and validate the IFC model using the independent checker, which is the Solibri model checker, which was used to check the IFC model before importing into Portal Structure, after which the design, it was also the IFC model exported from Portal Structure was validated through Solibri model checker, then passed to the Revit platform, which is the BIM authoring tool for drafting. Then this is a case study. We can see the architectural model and the structural model. Then straight to the design parameters for this case study. Three design parameters were noted, which are the live, dead, and the wind load. And we can see that we have 15 load combinations from the FEM platform. Now, these are the other parameters. I'm going to go straight. Now, for the first case study, we can see that this is the bidirectional inputter beam. Now, one of the challenges faced was Portal Beam does not allow mapping of slabs, walls, and footings. It just allows the mapping of the columns and beams alone in Revit. So what was done was to just create a structural model consisting of just the beams and columns, which was actually passed through to Portal Structure using the Portal Beam link. And after which placement of slabs and wall, the lift shaft tool was done in Portal Structure. Another notable challenge was Portal Beam does not allow the mapping of load cases and load combinations. So load cases and load combination was done in Portal Structure. And also it does not allow imports of those load cases and load combination because there's no adequate mapping of those parameters. So all load cases and load combination were done in Portal Structure before the design model was passed to Revit. And this is the second case study where IFC was used as a link between Revit's platform and the Portal Structure platform. Now we can see that after in Revit, the 3D model consisted of all elements: the structural column, the beam, the slab, and the relief shaft wall, which was also independently checked in Solibri, the IFC model checker, then before passing to Portal Structure. One of the notable errors or the challenge also for IFC was after importing the IFC from Revit to Portal Structure, there were displacements of beams practically due to neutral axis. The software was joining the neutral axis of the beam to that of the neutral axis always at the center of the beam. So he was using the neutral axis to connect to the column, whereby distorting the main geometry of the beam. So this correction was done in Portal Structure before analyzing. That was and also another notable error was the multiple creation of grid lines in brutal structure. And that was also corrected before design analysis was done. Before it was passed back to Rev. We can see that the structure shows a complete geometrically shows. Let's just go straight to the result. Now, the results showing here, you can see that comprehensively, uh, for the first trip, which is the first case study, which is the from Revit to structure using the Prota beam, at 54%. And notably, we can see that IFC geometrically was good in exports of geometrical elements. That's geometrically the elements IFC had 100% for the export of these elements back to Revit. While for the import, we can see that even if we had some little issues with the foundation, the footing, because it was not needed to place a footing before analysis. Footings are placed after analysis is done. So we can see also another notable error, like the challenge I mentioned earlier, was the load cases and load combination. None of this was achievable because there was no adequate mapping. And also IFC, one of the major challenge IFC supports geometrical element. When I mean geometrical element, geometrically, like the shape, size, and all, but when I talk of the load cases and combination, the IFC does not support that at the moment. Same with the Puta beam, where adequate mapping for this data was not done. Another notable thing was the boundary conditions. Now, when you are exporting a column from Revit to Prota structure automatically takes that column as fixed at the bottom. So I wouldn't say that was there was a transfer of boundary conditions because it comes as default in Prota structure. So going straight to the conclusion, like I said, comprehensively, the study shows that Prota being the first case study had the best result in terms of bidirectional interoperability of 54%. Prota being demonstrated good performance in exporting structural models from Revit to Prota structure, achieving a success rate of 54%. The IFC format provides a standardized approach to data exchange and is capable of transferring complex geometric information. The notable challenges were the lack of support for exporting certain structural elements like wall and slabs from Revit to product structure. That was Prota beam, and challenging of slabs in both methods also involved transfer of loads, combinations, and boundary condition. Discrepancies also in concrete grade was also highlighted, and a need for proper material mapping is needed. These are the shop drawings gotten from structural analysis after design, and that's it. Thank you.